You'll need to know all 4 brain neurotransmitters because they appear in your science reading and they appear in drugs that you might be prescribed. And so it's useful to know how these basic drugs function, how they relate to the different sorts of chemical substances that you ingest in your life for various reasons, and how they relate to one another. So the 4 general neurotransmitters, the kind of basic chemistry of your brain is acetylcholine, noradrenaline, also known as norepinephrine, dopamine, which we saw in Parkinson's and Tourette's. In Parkinson's, you have low dopamine and you need to increase it. In Tourette's, you have too much dopamine and you need to try to decrease it, so the Haldol decreases the dopamine. Serotonin we'll talk about in antidepressants. So serotonin is another common neurotransmitter that you'll hear the name of. 2 amino acids are important to brain chemistry. Glutamate, which is excitatory, so that makes your brain connections fire more quickly, and GABA, which is inhibitory, so that makes your brain synapses fire less frequently. And remember, the synaptic, how the synapse work. So there's a picture here that these chemicals will go, when you ingest these chemicals, they'll make your neurons fire and they'll ingest those chemicals into a synapse, and that'll get taken up by the next receptors for the next neuron. So that's the basic neurochemical structure of how neurons fire and function, and what makes the brain work in the way that they work. So inhibitory kinds of drugs will tamp down that reaction, will kind of keep those chemicals from being released, and excitatory drugs will create more of those sorts of chemicals. As we're going through different mind-altering drugs, you should know 2 of these for an exam. So pick your 2 favorite mind-altering drugs and learn what the name of the drug is, the chemical of the drug, and some of its phenospace characteristics. The first one, stimulants, cocaine, amphetamines, caffeine, increase dopamine levels. And so what the phenospace aspects of these stimulants are of cocaine and increased dopamine is high arousal and hallucinations. You may be a coffee fan. I'm a coffee fan. That's why I have a picture of the coffee right there. I have my coffee, in fact, just right here. Coffee is my favorite drug, and you might not think that coffee and caffeine creates hallucinations, but if you drink too much of it, you will have hallucinations. So try to, like everything, drugs in moderation. Second kind of stimulants, MDMA, also known as ecstasy, is an increase in serotonin and dopamine levels, and the phenospace aspects that go with this drug is feelings of love and perceptual intensity, and that's one of the reasons why it's used in the ways that it's used, which can be a good thing, but like everything else, should be used in moderation and with consent. And then nicotine is another stimulant that might be familiar to you, increases acetylcholine level, and phenospace aspects of nicotine are improved reaction time and attention. That's one of the reasons people like nicotine. Of course, it's an addictive drug, and so even if you might like this extra stimulation in a limited way, you won't be able to limit it after a certain time. That it takes over, it becomes addictive, and you have to get more and more in order to be able to maintain that level that you are looking for. Other sorts of mind-altering drugs are depressants. So the first batch were stimulants. These are depressants. Morphine decreases acetylcholine. Recall that nicotine increases acetylcholine, so you've got the same neurotransmitter with opposite sorts of effects. Here, when you decrease acetylcholine, the effects, the phenospace effects, are feelings of pleasure and well-being. So, opposite of increased attention and high. Alcohol also, keep in mind, is a depressant. It may reduce the activity of neuroadrenaline. I think they're still investigating exactly how alcohol functions. And its phenospace effects are to reduce anxiety and arousal, and to impair perception and memory. And in relation to that, judgment. So one of the effects of alcohol is that you don't realize that your perception and memory are worse than they normally are. So you think you're fine, but in fact you already are impaired. Antidepressants, so not stimulants exactly, but trying to remedy the effect of depression, are drugs that function to increase serotonin, and the most common ones are SSRI drugs, and those are selective serotonin reuptake inhibitors. So now that we know what a synapse is, what a serotonin reuptake inhibitor is that it stops the serotonin from going back up. So when a neuron fires its neurotransmitter into the synapse, it also sucks some back up. And so if you've got an inhibitor to block that reuptake, then more will stay in the synapse and then get taken up by the next neuron. So it effectively increases, a reuptake inhibitor effectively increases the amount of serotonin in the system. So SSRIs increase serotonin levels, and the phenospace effect is to increase arousal and your sense of well-being. And one of the things that's interesting in terms of thinking about these neurotransmitters and how they function, how these drugs function in relation to neurotransmitters. So, you have some stimulation, you have some depressants, you have antidepressants. How are they working on the system in different sorts of ways, and how does that need to be balanced in terms of your brain chemistry in order to keep your system functioning on an effective level, a sense of well-being, to have a sense of well-being. One of the things that Blackmore talks about in another context is the question of normalcy. And normal isn't necessarily the kind of state that we're looking for. We're looking for a state of well-being, that each of us has a slightly different brain chemistry, and that's one of the reasons why it's difficult in a therapeutic context to find the right drug and the right levels, because all of that needs to be balanced. And remember again, Sachs, in giving Haldol to Ray, there needs to be a way of thinking about the drug that you're taking that makes it effective. And so all of that is a matter of brain chemistry and the way in which the brain is responding to these chemicals. So keep that in mind as you're thinking about these mind-altering drugs. Next category of mind-altering drugs is anesthetics. So these are ones that are normally given when you undergo surgery of some kind or another, but they can also be taken in recreational contexts. So ketamine is an example of an anesthetic that's used in both contexts. It inhibits the function of NMDA receptor, so it operates to dampen the system overall, so inhibiting the system overall. Because that's one of the sort of general structures of the brain, and some of the phenospace effects are that ketamine disrupts memory, it induces dissociation, and generates hallucination. So you feel dissociated from yourself and you feel dissociated from the world in terms of generating hallucinations and experiencing perceptions that aren't of reality. Next category of mind-altering drugs is psychedelics. Cannabis, or marijuana as it's more familiarly known, although now that it's becoming legal places, I think people are much more aware of cannabis as the term. Possibly it stimulates noradrenaline, so I think more natural mind-altering drugs like herbs and alcohol, it's harder to isolate the specific neurotransmitters that are involved, probably a more complex effect on brain chemistry happens as a result of these, these sort of natural interactions. But similar kinds of effects as a result of taking this drug, hallucinations, feelings of delight or fear, perceptual intensity, impaired memory, and loss of time. And this idea that you might have a feeling of delight or fear as a result of this drug, and you'll see that in a number of the psychedelics. It's important to think about the context in which these psychedelics are taken. Blackmore talks about the importance of ritual in taking something like mescaline, the next mind-altering drug. So this structurally resembles noradrenaline, and the phenospace effects are hallucinations, perceptual intensity, sense of unity, loss of control and time. For mescaline in particular, that loss of control and time and perceptual intensity can be very frightening, or they can be, wonderful. So you might have a sense of unity as a result of taking mescaline, but you might lose a sense of unity if you lose your sense of control. So if you take this drug within a ritual context, then that context provides you an interpretive lens for that kind of hallucination. That's very, very important. Studies have shown that the interpretive context is really, really important to these sorts of hallucinations having a therapeutic effect. For a long time, drug-induced hallucinations were not allowed, particularly with the next mind-altering psychedelic, LSD. LSD was discovered, there was some amount of experimentation done in, I think, the 70s on LSD, and then the government just was like, nope, we can't have that. It got attached to the countercultural anti-Vietnam war movement, and so the government was like, okay, we need to have these people not be tripping out and get them back to reality, and so all research on LSD and other psychedelics was halted worldwide. Now in a number of countries, LSD research and other psychedelic research is entering back into the scientific context, and so actual therapeutic effects and actual brain effects and so forth are being studied more rigorously. And I think that's a really interesting development to see the ways in which some of these psychedelics can have really wonderful healing properties by virtue of these hallucinations, where a person can deal with something in a hallucination that perhaps that person could not deal with in a perceptual context. So again, be thinking about what that means in terms of how we're thinking about altered states of consciousness in relation to consciousness. What does it tell us about consciousness, and what does it tell us about reality? So LSD, as I was saying, is another one of our mind-altering drugs. It structurally resembles serotonin, and the phenospace effects of LSD are hallucinations, feelings of delight or fear, again, it can go either way, and a sense of unity. So very similar to mescaline. And mescaline is also known as peyote in terms of its plant name. So what do hallucinations tell us? What do they tell us about consciousness? Do hallucinations tell us that consciousness is more of a show? Do hallucinations tell us that there is a non-physical spirit that is going to another place, another reality in a hallucination? Do hallucinations confirm eliminativism, that we can explain all this stuff in terms of brain processes, and so we shouldn't even be talking about this extra stuff of hallucinations? What do hallucinations tell us about reality? So if you're a dualist and you think that in a hallucination or a near-death experience you go to another realm, you go to heaven, you go to some mystical place, which is an alternate reality, how do you know? How does the hallucination inform you about reality? What are the ways in which you can test that alternate reality for its knowledge gathering, its knowledge grounding sorts of features? Is a non-physical realm of existence implied by these hallucinations? And what does that say about our science of physics and the rest of the things that we tend to think of as reality in this world that we're experiencing? So be thinking about hallucinations, how they relate to mystical experiences, near-death experiences, out-of-body experiences, all the different sorts of altered states of consciousness that you have, and what they tell us. What can you learn from hallucinations? Can you learn anything from a hallucination, or is it simply a malfunction? These are the questions that are raised by altered states of consciousness for our final unit in considering what consciousness is.